presenting afternoon. So bye. 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 Good afternoon, students. Today we are discuss about the CPU scheduling in operating system. So already we have discussed process concept. So before going to this CPU scheduling, that means scheduling is nothing but so whenever the processes are executed inside the CPU, more number of processes are executed. So which process is that means at particular time which process is in running or execution mode. So that is find out by using this CPU scheduling concept. Now here, so coming to here, the now see the basic concepts for this CPU scheduling. Uh, so main intention of this CPU scheduling is here maximize CPU utilization obtained with multi-programming. That means maximize CPU utilization means what? Nothing but that means at any time the CPU is not in ideal position. Okay, so maximum utilization of CPU. So how that is possible? That means instead of executing one program, you can execute the multiple programs. Then CPU utilization, maximum utilization can obtain. That means suppose if we, in CPU only one program is executed, in that situation, uh, if that program requires any input and output or it reads something from somewhere else, in that case the CPU is in ideal position until and unless that read and write operation completes. So whereas in coming to the multi-programming, suppose if one program is use executed inside the CPU or some resource like CPU. So in that case, suppose if that process requires any data or read operation or write operation, so in that situation, that now the CPU preempt that process and execute another process, so that the CPU never goes to the ideal position. So this concept is called as so based on this concept, see maximum CPU utilization can obtain. Okay, so how it is possible? So that means suppose more number of processes are there. Out of this more number of processes, which process is executed under the CPU? That is what we decided by using this CPU scheduling concept. So here CPU IO, that means here two types of burst cycles are there. One is the CPU burst cycle and IO burst cycle. That is the process execution consists of a cycle of CPU execution and IO wait. That means whenever one process is executed in the CPU, in that situation, so once the process is executed inside the CPU, if that process requires any input and output, then after completion and execution of that particular process, and for that if that process requires any read and write operation, so now one cycle is complete. We can call this one cycle is completed. Means process execution consists of a cycle of CPU execution and IO wait. That means how much of time the CPU is in execution mode, and if that process requires any input and output, how much time the CPU is in ideal position. So this is what find out by using This is called as CPU IO burst time. This is called as CPU burst, uh, CPU and IO burst time. So now this CPU burst time is distributed. That means execution time is distributed to more number of processes. For example, here once the processes are stored, and here number of processes are added into this store, and that process is read from the file, that means CPU execution starts. So while executing this one, if it requires any input and output, it goes to the CPU, goes to the IO, CPU goes to the waiting for IO. That means until IO is completed, then only again the execution is starts. Now store in this situation, uh, that means that CPU assigns with another process for execution. That means CPU execution is there. Suppose if this CPU is again requires any input and output, again go to wait for IO. So that is called as IO burst. So like that, more number of processes are assigned to CPU for execution. Okay. So here this is the graph. That means how the multiple programs are executed. That means here, suppose here burst time in milliseconds, frequency, that means 0 to 20, that means how frequently, that means for executing this number of processes, that means for 160 process within the time, that means burst time is what, and then these are the number of processes. Okay, now before that, first see here. So how the CPU is executed, that means here. So for to obtain the multi-programming, we require the CPU. So before discussing the CPU scheduling, so first of all, so here that is the purpose of CPU scheduling. That means to obtain the multi-programming, we require the CPU. Okay, to obtain the multi-programming concept, we require the CPU scheduling. That means when the CPU scheduling is there, that means where that CPU scheduling is used, that means in the ready state. That means whenever the all the processes are stored in the ready state, ready queue, now the CPU scheduling is required. So who is done this CPU scheduling? Already we have discussed, this is short-term scheduler. That means in the process state diagram, we can discuss about these concepts. That means from how the CPU, that means process is created. So once by using the new, whenever the process into the new state, means the process is created. Means suppose our program is stored into the disk. So whenever we can execute that program, so, for example, you can execute some C program. Whenever you can compile that C program, it generates some OBJ file. After that, it generates, run your application, it generates some exe file. Now, that exe file is stored into the disk initially. So, that exe file is transfers into CPU or random access memory. So that means in the random access memory, number of processes are there. That means number of processes are nothing but. So now which process is ready to execute? That means whatever the programs are now ready to execute, those are stored into the uh, random access memory. That is the main memory. That means new nothing but all the executed processes are stored into the main memory. Okay. So this process is the done by the long term scheduler. So once that means number of out of these number of processes, some processes are stored into the ready queue. So this is done by the long term scheduler. So from this long term scheduler, that means from this ready queue, that means ready queue contains number of processes IDs, those are executed next are stored into the ready queue. From this ready queue, select one process and assigns the CPU. So that is which process is selected. So for that we require some criteria, that is called as CPU scheduling criteria. So this is done in the at ready state by short-term scheduler. So when this CPU scheduling is required, that means coming to the running state. Suppose if our process is in ready state, new state to ready state. So first one is the new state to ready state, from which ready to running. So which process is executed in the ready, that means running state. Okay, and here these are the situations. So first one is the here running to termination state. That means running state to termination state. Whenever the one process is running in the CPU, after completion of its process, it goes to the termination state. When the process is getting completed and running state is becoming, we need to bring some other process. That means which process bring to the CPU for running. So that means, so already executed process is completed and that process goes to the terminated state. Now another process is enter into the CPU. In that situation, which process is enter into the CPU, that is decided by the short-term scheduler. That concept is nothing but CPU scheduling. Okay, that means running to, and not only this, running state to terminated state, not only that one, and CPU scheduling also required at running state to wait state. That means some process is goes to the running state to wait state. That means whenever some process is executed inside the CPU, if that process requires any input and output, so now it goes to the wait state. In that state, the CPU never becomes the ideal state. So in that situation, in the CPU, another process is executed. Okay, that means running state to terminated state plus runnings to wait state. So whenever the process goes to running state to wait state, so at a time only one process is there in the running state. That's why whatever the process is in running that requires any input and output, so in that case that goes to the waiting state for IO operation. So in that case CPU is in ideal. So but to achieve the multi-programming, we cannot place the CPUs in ideal position. We cannot keep in the CPU in the ideal position. That means whenever our process is in running to waiting, and some other process that already there in the ready state, so assign into the CPU for executing purpose. Okay. So this is another case. And coming to the running to ready state, that is in the sense running ready to running in the sense, suppose sometimes that process is executed inside the CPU. So while executing that process in the ready queue, some high priority process will uh, that means some other high priority process can came into high priority process uh, came into the ready queue. That means whenever the high priority process is coming to the CPU, now first priority goes to the high priority process, so that whatever the process is running inside the CPU, so that process execution is stopped, that means preempted, and even some time is required for completion. uh, Before completion of that execution, whatever the process is executed inside the CPU, so that is terminated and stores into the ready state. So this is called as a preempted state. So whenever the high priority process came into the CPU, sorry, ready queue, now the running process is preempted and stores into ready queue. So this is one case. And another case is, suppose in the time sharing environment, suppose some number of processes are executed inside the CPU. While executing number of processes inside the CPU, while number of processes are executed inside the CPU, in that situation, suppose the time slot is completed, but our burst time is more than our time slot. In that case, so some partial execution is completed and some remaining execution is left over. So in that case, the process is terminated from the CPU or preempted from the CPU and assigned into ready state. So in these three cases, CPU scheduling is required. So other than this, wait to ready state. So once the IO operation is completed and now stores into ready queue. Okay, let us say we have process uh, P2, that is a low priority process. The process which is coming from wait to ready is a high priority process. That means uh, in the CPU, P2 process is executed. So after completion of IO operation for P1, okay, now P1 is stored into the ready state or ready queue. This P1 have highest priority compared to P2. Then P2 execution is terminated and P1 is assigned to the process. That means hence the CPU scheduling is required to perform the bring the high priority process into the running state. That means whatever the process is goes into a wait state. So if that process is the highest priority compared to whatever the process is executed inside the CPU. That means రన్నింగ్ ప్రాసెస్లో మనకి ఏదైతే ప్రాసెస్ ఉంటుందో ఆ ప్రాసెస్ కంటే వెయిటింగ్ స్టేట్లో ఉన్న ప్రాసెస్ యొక్క ప్రయారిటీ ఎక్కువ ఉంది. సో ఆఫ్టర్ కంప్లీషన్ ఆఫ్ దిస్ ఐఓ ఆపరేషన్ నౌ ద ప్రాసెస్ గోస్ టు వెయిట్ స్టేట్ టు రెడీ స్టేట్. మీన్స్ వాట్? That is stores into the ready queue. Once it is stores into the ready queue, now that process has highest priority compared to whatever the process is executed inside the CPU. Okay, for example, P2 is the lowest priority process and P1 is the highest priority process. Now the P1 goes to the wait state. It requires some input and output operation. After completion of input and output operation, now that process goes to ready state. But this P2 has highest priority compared to this this P1 has highest priority compared to this P2. Now this P2 is preempted from the running state and enter into the CPU. Now into CPU. That means running state. So in this situation also CPU scheduling is required. And one more is new to ready state. So new to ready state means, so whenever any process is executed in the CPU, otherwise suppose in the newly number of processes are newly created, those are stored into the ready queue. So in that ready queue, suppose some highest priority process is stored into the ready queue. Now that goes to the running state. That means in these three situations, running state to termination state, running to wait, running to ready. That means running to terminate, running to wait, running to ready. So both all of the three situations as well as wait to ready, new to ready. So in these five situations, CPU scheduling is required. So this CPU scheduling is done by the short-term scheduler. So where this CPU scheduling is done, that means in the ready state. So what are the goals of this CPU scheduling? That means the goals of this CPU scheduling are to maximize the CPU utilization and throughput of the system. What is the throughput of the system? Here, throughput of the system in the sense number of processes are executed at unit time is called as throughput of the system. That means if the throughput of the system is increased, nothing but maximum utilization is obtained. That means throughput means number of programs are executed at unit time. That is nothing but throughput of the system. Okay. So if the throughput is high, automatically we can say that maximum number of maximum utilization is obtained. And one more thing, to minimize the average waiting time. That means maximum times the CPU, the processes is waiting in the CPU. That means what? Maximum time the CPU, process is in waiting state or in ready queue. Automatically the CPU performance is very low. Okay, that means average waiting time minimize cheyali. Okay, and maximize the CPU utilization and throughput and minimize the average waiting time. So in these two situations, here CPU scheduling is used. And before discussing different algorithms in the CPU scheduling, so first of all we can discuss about this, whatever the concept till now I am explained. So that is done by the CPU scheduler. So that CPU scheduler is also called as short-term scheduler. Okay, the purpose of this short-term scheduler is select one process from number of processes in memory that are ready to execute. That means in the ready queue number of processes are there. Out of this number of process we can select only, that means CPU scheduler can select only one process and allocate the CPU to one of them. So this is done by the CPU scheduler. When it is, that means already we have discussed this, running to wait state, running to ready state, and running to terminate state also, and waiting to ready as well as new to ready. In all these situations, here CPU scheduling is required. So that is done by the CPU scheduler. And coming to here, out of these four different types of cases when the CPU scheduling is required, here 1 and 4 is non-preemptive. That means switches from running to waiting state and terminates. These are the non-preemptive. So whenever one process is enter into the CPU, so if it requires any input and output, so until and unless the CPU is assigned with another process, and this running process, whatever the running process, it requires some IO, it goes to the waiting state. That means in this case, this is not a preemptive versions, non-preemptive versions. Non-preemptive versions in the sense until the process assigned into the CPU, until and unless the execution completes only, the process comes out of from the CPU. Otherwise, the process is executed in the CPU itself. And coming to switches from running to ready state, waiting to ready state. So these two are these two are called as other scheduling algorithm, that means preemptive scheduling algorithm. So preemptive nothing but enti, suppose some process is executed inside the CPU. So while executing that process, if highest priority process came into the ready queue, now that is terminated. And one more thing, if that process requires any input and output, then also highest that process can preempt it. Okay, in the time slots also. Okay, now see here, continuation of this CPU scheduler. Here, this next we can move to dispatcher. So what is the dispatcher? That means dispatcher module gives the control of the CPU to the process selected by the short-term scheduler. That means short-term scheduler selects one process. Now that goes to the ready state. So for that ready queue నుండి ఏమవుతుంది మనకి some process is selected. That is done by the short-term scheduler. And now after scheduling that one, now that is executed in the CPU. Now this CPU, while executing that CPU, so if it requires any input and output or any high priority process came into the ready queue, otherwise any that means time slot is completed. So in these three situations, whatever the process is executed inside the CPU, that is terminated. That means that is terminated and other process is assigned into the CPU. That means some other process is dispatched to the CPU. So that is done by the dispatcher. That is, this dispatcher module gives the control of the CPU to the process selected by the short-term scheduler. This short-term scheduler selects one of the process from the ready queue. Now, whatever the process is selected from the ready queue by the short-term scheduler, that is assigned to the CPU for execution. So that is the responsibility of dispatch modular. So here the dispatcher modular purpose is, one thing, suppose some 10 queues are there in ready queue. Out of these 10 queues, one queue is selected by the short-term scheduler. So after selecting this queue from the short-term scheduler, now that queue means that process is dispatched to the CPU for execution. So that is done by some module. That module is called as dispatcher. Okay, this dispatcher purpose is switching context. That means switching to user mode. Jumping to proper location in the user program to restart that program. That means switching one process to another process, otherwise switching to user mode. Next, jumping to the proper location in the user program to restart the program. And dispatch latency. What is the dispatch latency? So coming to the dispatch latency, time it takes for dispatcher to stop one process and start another process. That means suppose one process is executed inside the CPU. So if that process is terminated or preempted or non-preempted, in both of these two situations, another process is enter into the CPU. Another process is enter into the CPU only. So while another process is enter into the CPU, in that situation, some time is required. That time is called as dispatch latency. That means time it takes for the dispatcher to stop one process and start another process. That means stop one process. What means whatever the process is executed inside the CPU, that process is stopped sometime and some other processes enter into the CPU for execution. That means how much of time gap between stopping and stop one process and start another process. That time gap is called as dispatch latency. Okay. Now we can discuss about the scheduling criteria. That means when the scheduling is required, whenever the processes goes to running to terminated state, running to wait state, or running to ready state, or wait to ready state, or new to ready state. All these situations scheduling is required. This scheduling is done by the short term scheduler. That means which process is selected from the ready queue, and after that who is done that scheduling concept. This scheduling concept is done by that means short term scheduler, where it is that means from where scheduler can select the processes for executing. That means ready queue. That means CPU scheduling is done on ready queue. Who is done? Short term scheduler. When that is run, that means ready to running to terminate, running to wait, running to ready, and wait to ready, new to ready. So for selecting particular process, so here some scheduling criteria is there. So that scheduling criteria is CPU utilization. That means how much of CPU time is required to execute that process. That means CPU utilization. Keep the CPU as busy as possible. దట్ మీన్స్ ఎంతవరకు మనకి సిపియూ బిజీగా ఉంటుందో అంతవరకే సిపియూని మనం బిజీగా ఉంచాలి. దట్ మీన్స్ నంబర్ ఆఫ్ ప్రోగ్రామ్స్ ఆర్ ఎగ్జిక్యూటెడ్ ఎట్ ఏ టైమ్ ఇన్ ద సిపియూ. దట్ మీన్స్ నెవర్ కీప్ సిపియూ ఇన్ ఐడియల్ పొజిషన్. అండ్ కమింగ్ టు ద థ్రోపుట్, number of processes that complete their execution per time unit. Certain time unit lo how many number of processes are executed, so that is called as throughput. Turnaround time means amount of time to execute a particular process. That means this is also called as um, how much of time is required to execute particular process. That means particular process execute కావడానికి మనకి ఎంత టైం అవసరం. That is called as a turnaround time. Waiting time nothing but amount of time a process has been waiting in the ready queue. So the turnaround time means when the process execution completed, that is the turnaround time. And coming to the burst time, how much of time is required to execute that one. That means both of these two are different. Turnaround time and burst time both are different. Coming to the burst time, how much of time is required for executing that particular process. Here this is a mistake. Coming to the turnaround time, suppose P1 is executed 5 minutes and P2 is executed next to 5 minutes. What is the turnaround time for that P2? That is a 10 minutes. That means first 5 minutes it is in waiting and next 5 minutes it is execution. టోటల్గా ఎప్పుడు మనకి ప్రాసెస్ కంప్లీట్ అవుతుంది, 10th సెకండ్లో ప్రాసెస్ అనేది కంప్లీట్ అవుతుంది. సో అల్టిమేట్గా బస్ట్ టైం ఎంత? దట్ ఈస్ 5 seconds. మీన్స్ turnaround time nothing but amount of time to execute particular process. And coming to the response time, amount of time it takes from when a request was submitted until the first response is produced. That means సో మనకి ఫర్ ద ఫస్ట్ టైం అది ఎప్పుడు ఎంటర్ అవుతుంది, ఆఫ్టర్ దట్ అది ఎప్పుడు ఎగ్జిట్ అవుతుంది. ఓకే, సో ఇది మనకి బస్ టర్న్ టైం అంటాం. కానీ రెస్పాన్స్ టైం అంటే ఏంటి అంటే అమౌంట్ ఆఫ్ టైం ఇట్ టేక్స్ ఫ్రమ్ వెన్ ఏ రిక్వెస్ట్ వాజ్ సబ్మిటెడ్. అంటే ఎప్పుడైతే మనకి ప్రాసెస్ వచ్చేసి రన్ అవ్వడానికి సిపియూకి అసైన్ అవుతుందో ఆ టైంని ఫర్ ద ఫస్ట్ టైం. అంటే ఫర్ ఎగ్జాంపుల్ సపోజ్ P1 ఈజ్ ఎగ్జిక్యూటెడ్ at 1 millisecond. So after completion of 5 milliseconds, at 6th millisecond, some other processes came. That means highest process. Now this P1 is comes out of, and next another process is executed, that is a P2. So while executing this P2, another priority process P3 is entered. So that P3 entered at for example 10th millisecond. Now after 2 seconds again P1 is entered. Then 12th second the P1 is entered into the CPU. After 2 seconds the P2 is executed. That is the 14th second P2 is executed. After 2 seconds P3 is executed. That is 16th second P2 is executed. So in these three cases, so P1 first response time is 1 milliseconds. P2 first response time is 6 milliseconds. P3 response time is 10th millisecond. So that means ఫస్ట్ టైం ఎప్పుడు మనకి అది సిపియుకి అసైన్ అవుతుంది. సో దట్ టైమ్ ఈజ్ నథింగ్ బట్ ఫస్ట్ రెస్పాన్స్ ఆర్ సింప్లీ రెస్పాన్స్ టైం. సో వైల్ ఎగ్జిక్యూటింగ్ ఎనీ షెడ్యూలింగ్, దట్ మీన్స్, so here what is the purpose of this CPU scheduling? That means these are the concepts. To achieve the maximum CPU utilization, never keep CPU in ideal position. As much of as possible, you can keep that CPU is in busy. Okay, number multi-programming is obtained. And coming to the maximum throughput, that means per unit time, how many number of programs are executed. So that is nothing but maximum throughput. And coming to the minimum turnaround time means తక్కువ టైంలోనే మనకి ఎగ్జిక్యూషన్ అనేది కంప్లీట్ అవ్వాలి. మినిమం టైం మనకి అది వెయిట్ చేయాలి. రెస్పాన్స్ టైం కూడా మినిమం ఉండాలి. సో మినిమం టర్న్ అరౌండ్ టైం, మినిమం వెయిటింగ్ టైం, మినిమం రెస్పాన్స్ టైం. సో దెన్ achieve this maximum CPU utilization and maximum output. So this is the optimization criteria while using the CPU scheduling algorithms. Here two different types of CPU scheduling algorithms are there. Those are preemptive scheduling algorithms and non-preemptive scheduling algorithms. So coming to the preemptive scheduling algorithms, nothing but whenever one process is executed inside the CPU, so highest priority process are based on the time slot, whatever the process is executed in the CPU. So um, that is but burst time is not completed. That means some execution is required even though that process is comes from the CPU. That concept is nothing but preemption. Preemption complete కాకముందే preempt CPU నుండి empt చేస్తున్నాము. So that is nothing but preemption concept. So whenever the preemption is there, so you can observe one thing, that process is not completely executed. Some partial execution is there, some more execution is remaining. Okay, and one more is the non-preemptive scheduling algorithm. Coming to the non-preemptive scheduling algorithm, so once the process is assigned into the CPU for execution by the dispatcher, so dispatcher selects that process, which process that is selected by the short-term scheduler. So once whatever the process is executed in the short-term scheduler, that is selected from the ready queue by the short-term scheduler, that is takes by the dispatcher, that is dispatched to the CPU. In the CPU, that process is executed completely. Not means that is not preempted, means until whatever the burst time is assigned to that process P1, burst time complete ayanta variki that process is in execution mode. So now it is called as non-preemptive scheduling algorithms. So some algorithms have both versions, non-preemptive scheduling version and preemptive scheduling version. Some algorithms have only preemptive versions and some algorithms have only non-preemptive versions. Now we can discuss those algorithms one by one. So this first one is the first come first serve manner. In this first come first serve manner, here this is what non-preemptive scheduling algorithm. So whatever the processes are there in the ready queue, so which process is in the first position, so that is first served. That is first served. Here P1, P2, P3 are the processes. These are the burst timings. 24, 3 are the burst timings. Okay. So in this case, in this case, here how the processes are executed. So process execution is shown like this figure. So this is called as a Gantt chart. This is called as a Gantt chart. So for every scheduling, every different types of scheduling algorithm, first you can draw the Gantt chart. And suppose that the process arrive in the order P1, P2, P3. So processes are arrived in order P1, P2, P3. That means P1 stores in the ready queue first time, next P2, next P3. In the ready queue, P1, P2, P3 are the processes. So first which process is processed? That is first P1 is processed because this is the first come first serve manner. So whichever the process first came into the CPU, that process is first processed. Okay, P1 and at arrival time is 0. At 08 seconds, P1 is entered into the CPU and his execution its execution time is 24. Okay, after completion of this 24 milliseconds, P2 enter into the CPU. Now its burst time is 3. That means what is the turnaround time here? 27. So after completion of 27 milliseconds, P2 is executed. And after completion of P3, 30 milliseconds, P3 is executed. Now, in this case, you can observe what is the waiting time for this. Coming to this waiting time, here you can observe the waiting time for, in the point. So here P1 is not waiting.